Good morning, everyone. Do we have a cat around? I think Tuco's hanging out upstairs for now. Welcome back. Oh, there he is. Hey, Tuco. Oh, yeah. Eventually I'll actually know which of these buttons go where. But right now it's a little bit of a crapshoot. Oh, Tuco. He, of course, jumps onto the most sensitive equipment. Such cat. Hey, Tuco, you want one of these? All right, well, maybe Tuco says we start with a little bit of this. It's not a bad way to start a stream anyway. Give a little bit of context while the cat gets a chance to get some of this out of his system. Otherwise, he'll be bothering me for playing just all day. I know last weekend I was talking about finishing the project with the squishy buttons, but I think maybe I'll actually do it today. That one's been kind of dragging out a bit. It's one of those projects where I find myself being probably too much of a perfectionist, and the urge to just finish it starts building. But it's pretty close. I'll get it on camera and show what the current progress is in just a sec, but it's pretty much ready to glue together at this point. Modulo a couple of small problems. It looks like a couple of the tactile switches need replacement. I didn't actually test these tactile switches before installing them, and I think this might have just been a batch of kind of low quality ones from eBay, and a couple of them aren't so good. So that'll just be a little bit of surface mount soldering to replace those. But I've got all the parts designed and printed. I'm currently reprinting one of the pieces because I wasn't super happy with the quality, but we can decide whether or not to wait for that print to finish. Just catching up on the chat slightly. Seems like any project with 3D printing will take a lot of time to finalize. That's probably true. Although it's funny because 3D printing is in some ways way faster than the alternatives. Like if the alternative is sending out for some parts to be manufactured, then it's way faster. But if the alternative is just like cutting something out with scissors or making something else small with hand tools, then it's going to be way slower. So in some ways, you know, there might have been faster ways to make this. Like if I just hot glued a bunch of buttons to a piece of foam and wired them together by hand, that probably would have been faster, but, and it might have still been flexible. But I think part of this project was I wanted to try out the techniques and maybe get something that, you know, that was kind of challenging in a few new ways. I guess I'm not too content to just make something that I already know how to make. I want some risk in there. I got to figure out how to do something new in the process. Hello, Richard from the UK. And Happy New Year to you too. Yeah, I hope everyone has a great New Year. I hope 2017 isn't terrible. That's my wish for 2017, not to be terrible. It's going to be a tall order, but you know, gotta be optimistic, I guess. It really is kind of crazy just how many people have died. I mean, everybody, you know, every year, lots of people die, obviously, but I guess the general mood of 2016 being a giant dumpster fire was really helped out by, you know, people passing away. In terms of, famous people, but also was remembering, well, I've been watching a bunch of the CCC talks, which I definitely recommend for anybody who hasn't been able to go to CCC, which includes me. I still have not made it to CCC in person, but I really enjoy watching the talks. And I was finally getting a chance to watch Hector Marcan. He did a talk on some of his PlayStation 4 research, and so he's got like a port of PS4 or of Linux to the PS4 again, which is pretty cool. And he and I kind of know each other. Like we worked on some video game hacking stuff back in the day. But he also, knew Ben Beyer or Bushing, who passed away in February, and had a little tribute to Bushing in the talk, which was nice. But that was so long ago. Like, it was a little surreal to realize that was also 2016. That was near the beginning of 2016. But Happy New Year anyway. It'll be nice to get a bit of new clean slate to start scribbling over. This cat has been super in the mood to play with bolts, like, the last couple days. I think I might have been getting into my projects a bit too much and ignoring him yesterday, so now he's like, I really want to play. Also, I'm like temporarily out of his favorite cat food, so I think he might be annoyed at that. I've been giving him this kibble that, like, he used to be his everyday food, but he's gotten really into this chunky salmon stuff lately, and now that I'm out of that, I think he's been like, where is it? I'm like, it's on its way. I pressed the order button. But, oh, cat. Let's see if I can get back into the multitasking here without Tuco getting too mad at me. Can we have 3D printer now? There we go. All right, so the printer is working on kind of a reprint of this, which is, right, that's the camera. I'll put this on a better camera in a sec, but this is kind of the overall top piece of the flexible button contraption. So it has individual spots for all the buttons, it has a place for the teensy, it's flat on the back. Oh, is Tuco finally relaxing a bit? All right. Okay. Oh yeah. Let's get that recording. I'm really tempted to work on this too, even though it's not at all related. I just got this out of the mill yesterday, and it's for work. So I probably shouldn't work on it over the weekend, but I'm anxious to populate it. It's just another voltage glitching board. Space for a few MOSFETs and MOSFET drivers. But I really like the way these freshly milled copper boards look. All right, this is what I've got so far. So these, the ones I have tape over are the ones that were misbehaving a little bit. So they all feel fine. They're all nice and clicky. But these were not really electrically reliable. These three weren't working at all, and this one is kind of intermittent. So I was going to try to replace those buttons. Oh, there's too much tape here. I need to get into that good, like, relaxing vibe for working and streaming on the weekends. Like, it's nice when it doesn't feel like there's all this deadline pressure on, and I mean, not that I have like a lot of deadlines right now in my day job either, but which I feel super lucky about. But it is nice I don't know, it's nice just having kind of open hacking time together with folks online. It's kind of nice when that can be the format. All right, so part of the reason I have this metal plate down here is this whole thing is designed to be magnetic, and so I'm going to be assembling this with some glue, and I wanted to kind of glue it up on the magnetic surface so the magnets hold themselves into place. So let's take this apart carefully. Hey, Tuco. What do you want, little guy? Alright, so this whole thing is a few layers. I have this back piece, which is flat on one side. These are not holes, they're just really thin areas. Yeah, so the back side is flat, and then the inside has pockets for the magnets, and a really shallow pocket for the flex PCB that actually holds the buttons. So the magnets, I placed them, with a couple of different constraints. I tried to put them along the edges so that they would, hold this to curved surfaces. I placed a couple in the middle where there was room. This was also constrained by just how many of these magnets I had handy. So I had 16, so I made room for 16 on here. And what else? Here we go, some test pieces. Of course, all the tape marking which ones were not functioning just came off, so I might have to retest those a little bit. Anyway, here's another relevant test piece. Camera, here we go. So this is just two pieces of NinjaFlex. I was using this earlier to test thicknesses, and this is a test for the adhesive I'm planning on using. It's this E6000 glue. I have a bunch of it because I was using it earlier for a project with a lot of glass, because it bonds to glass really nicely, and it dries clear, and it's flexible. So I was just using that to stick together two layers of NinjaFlex, and they stay quite flexible once they're glued together, and they stick really nicely. It is possible to peel them apart. So for example, I already started peeling this a little bit, so it's maybe easier than if it was kind of just glued. But so there, the glue is holding it pretty sturdy, but I can peel it apart. So it seems like an okay choice for something where, I might want to take this apart to fix it in the future and then re-glue it, but it should avoid coming apart during normal use, I think. If it's a problem coming apart, I might have to do something more intense later, like heat seal the edges. But for now, I kind of want this to be disassemblable if I need to service it later. So I think some glue that holds pretty well, but I can peel off relatively cleanly, might be a good bet. And it's tough to find the excuse me. It can be tough to find the edge of this stuff, but once you get it started, it tends to peel off in a fairly clean sheet. Yeah, it's kind of like rubber cement or something like that. So, and then as for gluing it, there actually is not a huge amount of surface area for the glue to contact, but I tried to make sure that, so all of this flat area between buttons, that's where the glue is going to be holding this together. So I wanted to make sure there was a good way to press that together without unintentionally gluing the buttons down or deforming the whole contraption. So that's why I designed this piece. And it's just a hard PLA printed kind of mold that the flexible piece sits into. So, for example, you take this, and it just presses exactly into that cavity. bit of a tight fit around where the teensy goes. But yeah, now that's totally flat on the surfaces that need glue applied. And so the idea is I'll have the other end stuck down to the metal with magnets, then I'll stack everything up, add the glue, put this on top, and then just put a weight on top of this until the glue sets. So, and then, so this top piece has a lot going on actually, and it might be easier to look at this piece in CAD. But it's basically built around these buttons that are all, let's see if I've got the prototype for that. So the buttons are all based off of this design. So there's a little plastic insert in the middle. Actually, I have different colors of this insert. It might be easier to see with something other than this pink. Maybe the white ones show the details better. Or maybe the blue ones. I tried a few different colors that I had handy. I don't have a lot of PLA colors on hand, but these were little, so I didn't need much filament. So the plastic doodad in here is necessary as a force spreader to, it acts as a lever when you press the button to make the active area of the button cap wider than if I was just setting this directly on top of the little tactile switches. The tactile switch in this case is really little. So this is kind of a homemade flex PCB that I did on an earlier stream with the mill, and it's just got a bunch of these little kind of brass capped tactile switches soldered to it, and then the board itself is super flexible. So then these pieces, they have kind of a flat top, but a little bit of reinforcement on the bottom so that they can slide around without catching on the button and stay pretty rigid. And there are these two little flat spots that contact the circuit board when the button top kind of bottoms out to prevent it from tilting too much. And then the last feature that's worth pointing out are these little kind of crescent-shaped indentations, and that's where it actually hooks onto the flexible part. So I've got a bunch of those printed out. So each of these buttons in the flexible portion has a oh man, this autofocus. Let's actually use the autofocus again. So yeah, each button has it doesn't print super flat, but this is modeled as a flat region. And in practice, it ends up being a little droopy because of the severe overhang there. But it's not too bad as long as the actual amount of material there is kept pretty low. So when you put this little insert in, when you put that insert in, it actually just kind of clicks into place with those little nubs there. And now the whole inside part of the button, when it moves, oops. If you push on it too much without backing in place, it'll pop out. But as you push on the button now, that interior plastic piece with the little sort of lever pieces moves, and the external part can move fairly independently from that. So this is really just like a bunch more of those. And then space for the magnets, and this is all designed to be self-supporting as it prints. So for example, the teensy here, as it builds up from the print bed, first it makes this bridge horizontally, and then after that's pretty stable, it builds up another bridge here, and then it kind of bridges across this whole top eventually. So this prototype down here, let me take this apart. everything just press fits into this. So that's the delicate circuit board so far, which needs a little bit of work just to replace those buttons that are misbehaving. And then this is the fully populated flexible part. And I was trying out different colors of button caps. And as you can see, because the NinjaFlex is kind of translucent, but really blends in its own color quite a bit, the colors desaturate a lot. I don't know if I would necessarily use the colors to code for different meanings with this, because I'm more interested in making this something I don't really have to look at, but I can just feel the different button caps. But this has let me kind of check out the different looks that are available. I made a small modification to that top to try to add I'm getting a little ahead of myself. So this was actually not even intended to be the final version. This was like a test print. This was the first time I had actually tried printing a lot of these buttons together. And this was also the first time I'd tried printing this enclosure for the Teensy. But it all actually ended up working pretty well, so I didn't end up changing the basic structure of this. I just ended up adding some missing features where, so this design just had all the buttons replicated identically, but I really want the buttons to have a unique feel to them. So my vision for this is something where I can just kind of stick it somewhere where it's within reach but out of sight, and then I can just feel for the button I'm interested in and press it. So I think these rows of 3 buttons are pretty distinguishable based on their position left to right, but I want each of these individual rows to be pretty unique from the other rows. And it would also be maybe nice to have some visual continuity between the members of the rows. So that's what led me to this design, which actually is really hard to see what's going on because the visual structure didn't turn out so great. But they feel actually pretty much like I was hoping they would. So I'm going to try to illustrate this in a sec in CAD and show you what I was kind of going for. But this has the same structure for the Teensy. I added these little kind of asymmetric ridges to the exterior of the buttons to kind of point between the members of each row. And they're actually really hard to feel, it turns out, because I didn't raise them up. So like, vertically, they're flat with the edges of the button rim already, and they make the button rim wider, but with your finger you can't actually feel that unless you're kind of getting in there really. So maybe when this is curved, that'll be a little more noticeable, but right now that's probably too subtle. But I don't think I care enough to actually remodel it. I think I'm happy to let that be, since I don't think the rows really need that much additional help tying the rows together. I might do that with colors, like I might have the rows alternate colors perhaps. But then it's much more obvious in the CAD model and by feel, but if you get this in just the right light, you can see these symbols that are raised onto the buttons. So this top row has these kind of 2 vertical bars, this one has a 1 vertical bar, this one has a circle, and this one has a horizontal bar, and this one is blank. So based on those feels, I can actually pretty quickly identify which row I'm touching. But I also, when I printed this, I changed the layer height from 0.15 to 0.1 millimeters. And this was just because I was running the print overnight and I thought it would help quality, and I had the time to do it. But I think that might have just made some of the bridging work out less successfully. So, for example, there are all these holes in the top layer, which don't really affect the feel, but visually they make this thing look kind of ratty. And the main concern I have in it is it makes the kind of brightly colored overlays where they would normally just add like a little bit of subtle color. When the bright color shines through the hole, it just totally ruins the look. So, try clicking a couple of these in here. I keep getting these out of camera when I'm actually putting them in, I know. Usually having the monitor over there is useful, but sometimes I want the monitor like right here. Before I got this whole streaming setup put together, I was using this little like 8-inch monitor for the camera viewfinder, and I could just clip it on to the desk in front of me, and that was kind of nice. So, yeah, see, like this kind of makes me happy, but that hole is not so great. So, a couple of solutions to that. I'm currently reprinting this piece with a 0.15 layer height, just in case that helps. That'll probably take like another 3 or 4 hours. So I might feel like waiting for that. If I don't, then, or if it doesn't help, then another option is to just fill in this hole manually, like get a little bit of NinjaFlex and just kind of melt it on there and smooth it down somehow. Another option is just to use white inserts to make the holes less noticeable. Alright. So, yeah, this one that I printed at 0.15 actually feels really nice and much more consistent, but I mean, that might just be because the shape itself is more consistent. And these little holes for the magnets should end up acting like alignment pegs to keep the layers together. Since there's a bunch of them around the edge and they fit pretty nicely into each side. All right, let me check on the chat briefly, and then I think the next stage here is to... Oh, well, I have a little bit of software to talk about too. I guess I could go to the CAD and computer and get some of that on video. But yeah, document a little bit of that, and then probably the first actual, actual work to do today is to replace those buttons on here. Oh, there was just some general questions in the chat about what this is and what I've been working on. This is sort of a side project that is both a kind of self-referential doodad to use on these streams, but also a way for me to collect some footage for just general circuit assembly for an upcoming video about that, and also just a separate project that I'll probably do a video on its own at some point soon too. But aside from this, I've been doing some work with fault injection, like VCC glitching and magnetic glitching to try to extract firmware from devices. So I've got a video out on that for USB devices, but I've also been working on trying to do something similar for Ethernet. What else? I've got, so I mentioned the circuit board assembly. So I've been doing some stuff kind of like that. I've also got kind of this sprawling project that I really need to try to wind up, where I was reverse engineering a Wacom tablet and then using the code execution on the tablet in order to read an RFID card that was placed on top of the tablet. So I already partially documented that in the form of a POC or GTFO article, but I want to finish doing a series of videos on many of the steps behind that. So one of the steps there was just a kind of intermediate tool that I needed to build to disassemble the firmware on the tablet. So I just did some streaming about that, but I need to do some video editing and kind of really get that video put together. Anyway, let's go to the computer. There's the print in progress. Is this recording? Yes, great. So yeah, this is the current print, the 4-hour one. I can illustrate some of the buildup here. So you've got a couple layers that are pretty solid, and then right there is the first big bridge that it has to print, and then I give that a couple layers to let it establish, and then it prints another bridge, and then starts doing some more serious fill-in around the edges, and then just all of a sudden, now we're bridging between these long edges, and it does that pretty okay. This also has the side effect of visually hiding the Teensy's reset button while still making it very pressable. So if you need to reset it to get back to the bootloader, it's pretty easy to do. And then with these buttons, it's got a couple of open layers. And then right here you can see this dividing between the button's surround and the actual kind of inner layer that flexes. And then right here it's bridging over the area where it leaves room for the surface mount components. So from here up it's trying to be circular again. And so the surround builds up pretty straightforward. Like, the inner area stays pretty thin, and it's hard to tell here, but it zigzags a little bit to make it a little more compressible. Like there it kind of moves out and in. And then there's a little bit of a gap between these bumps and the top where the actual insert sits. And then there's just lots of bridging. And then it starts actually drawing the symbols on top of the buttons. And those will be a little easier to see in CAD. Oh, Tuco's back in his usual spot. Such a cat. All right. So this is most of the design. Let me turn on some of the other layers. Yeah. And magnets. Cool. So yeah, that's like the whole thing in CAD. It's a lot like what we were just looking at, but now you can kind of see these shapes a little more clearly. And they're raised a decent amount. They come almost to the edge of the button themselves. So it won't stick out beyond the profile of the button, but it's definitely noticeable. You can see if it take out all the NinjaFlex layers, this is just what it looks like with the button and the plastic insert. And the room for all the surface mount parts. And then there's just the bottom. So you can see here the Flex PCB is supposed to, like, it's about as thick as one layer on the 3D printer. So it's basically just left out one layer's worth of plastic here for the flex board to occupy. And then the Teensy itself is supposed to sit pretty much flat there. This doesn't actually account for the thickness of the solder joint, but I don't think it's going to matter. This material here is so flexible. And this fillet here was kind of my effort to try to protect the flex joint. I don't quite know if it's going to be enough, but like I tried to have a pretty smooth gradient from kind of stiff to flexible there. And I'm hoping that with that glued together, it'll also help. And then some room for the USB Type B connector. Okay, let's switch to the other computer where I think I have the Arduino stuff going on. So on the last stream, well, not the last stream, but the last time I worked on this, I had a little Arduino sketch that was kind of an example for like 4 buttons. And for that, I was assuming that there is kind of a linear spacing between the buttons. And that works when you have kind of a resistor ladder that you're sampling, and that's the only thing in the system. But we also have the pull-down resistor, which is not negligibly high. In this version of the circuit, I'm using, well, let's actually open the circuit. Visual aids are better. And I'm going to want as much visual as I can if and when I actually edit this into something. So let's do. Yeah, so this is important. And all right, this is the schematic for the flex circuit we have. So on the right side, that's just a lot of resistors in series acting like a potentiometer. So it's dividing the voltage between ground and +5, which is our A to D reference in this case. And when you push one of these buttons, we're kind of selecting one of those taps, just like if you'd moved the wiper of the potentiometer to that location. And then that connects to an analog input pin on the teensy. But when you're not pressing the buttons, we need this to read a reliable value. So in that case, this pull down pulls it to ground. But the pull down value here is not so high that we can just completely ignore it. It actually forms a voltage divider with the impedance of this entire divider circuit. And if you imagine that when you press one of these buttons, you're replacing this whole circuit with an equivalent resistance to VCC and an equivalent resistance to ground. You also, so you end up with, let's see, I'm trying to think whether I want to get into like Thevenin equivalences in this. Because in like, I don't know, like they would teach you in like first year electrical engineering that you can replace this with an equivalent, resistance, and that's like one way to calculate this. But yeah, maybe that's the most straightforward way to explain it. So, like if you imagine that this part of the circuit here, this whole resistor ladder, is like a black box, and you are over here measuring the resistance between this circuit and your power supply rails, then that resistance would change depending on which button you're pressing. So if no button's pressed, then it's effectively infinite. If you're pressing this button all the way to the end, it's a little bit higher than 1.6, or a little bit lower than. If you're pressing this button way over at the end, then the resistance is actually just a little lower than 1.6K, because you can imagine this resistance here is in parallel with a higher resistance over here, and 2 resistances in parallel are always going to end up being lower than either of the 2 source resistances. So just by doing just by intuition and not even doing the math, you can tell that this resistance is going to be lower than 1.6K. Whereas if you pick a resistance closer to the middle, you notice on this side, this is several times 1.6K, and this is several times 1.6K. And so if those were equivalent, then you would end up with a resistance that's half that value if those were exactly in the middle. So just kind of looking at this circuit without calculating it, you can tell that the resistance in the middle with one of these middle buttons pressed would be a lot higher than with one of these end buttons pressed. So I don't know if it's worth like going super deep into this and like graphing it. It's like if I was doing a video just on this, that's probably what I would do. But since this is probably just going to appear as a really minor point in something else, I don't think I'm going to worry about it too much. But the upshot of this is that even if you were just looking at this voltage divider and you're seeing that as a totally linear set of voltage taps, even if all these resistors were totally ideal, the addition of this voltage divider here with this resistance and the pull-down resistor makes it nonlinear, because now this resistance is changing in a nonlinear way depending on where you are in the ladder. So the effect of the pull-down resistance on that value changes in a nonlinear way. So we can see that in action, since I actually already graphed those values in order to test the circuit. So here I was running an Arduino sketch that just reads the ADC and prints it out over the keyboard. And so I run this in Notepad and sort all the values. So you can see that down here, these are all the values that I got when no key was pressed. So there's actually quite a wide range here, because when you release a key, that 47K resistance is so high that it actually kind of settles to 0 relatively slowly over the course of many milliseconds. So there's kind of this slow decay as it gets closer and closer to 0, but never quite reaching it. Then these plateaus are where we get a stable voltage from pressing just a single button. So I measured all those plateaus separately and put them into another page on this spreadsheet and just graphed those. That ended up way at the bottom. So here you can just see this is the button where 0 is no buttons pressed, and then here's all the actual buttons from 1 to 15. And here's the kind of plateau value I measured in the analog to digital converter values. And here's just this divided by this. So you can see that if, so I didn't actually do the division here because that would have been a division by 0, but this is an average of all the rest. So this is the value in kind of ADC counts per button index that we would get if this was all linear. And under that linear assumption again, here's the average, and then here's what we would get if we divided that ADC value by the average. So again, assuming it's all linear, this should get us back to the button ID. And it works pretty well at the extremes. So here, that's really close to 1, and that's really close to 16. But then we can see a lot of deviation here where, especially around here, so theoretically, if all of our resistor values were ideal, we would see the biggest deviation from linear right around the middle. And so some of these are actually pretty bad, like this is close to 0.5, which means we can't really tell which is being pressed. Same here. But some of these deviations are probably also just due to the resistors having a high tolerance. So instead of just calculating that, because so much of this is resistors having a high tolerance, and so even if we calculated the ideal curve here, we wouldn't be hitting it, I just made a lookup table. I just took these values and put them in a table, and so I'm saying we're just looking at which of these the ADC reading is closest to, and here's the corresponding keyboard key. And for actually switching inputs on my camera setup, I plan to use some modifier keys, but for testing this, it's easier for it to hit the buttons without the modifiers. You can just see it show up in a regular text editor. And because there's so much asymmetry between the resistance when you're pressing the button and when you're releasing the button, there's a lot of asymmetry too in the amount of time it takes for that reading to settle. So when you press the button, it settles to a plateau, like a stable value in the ADC very quickly, and then we can say this is what we pressed and have a pretty reliable idea that that's what's going on. But when you release the button, it actually kind of slowly settles to ground. So when I was using kind of a symmetric algorithm where I detected it the same way for press and release, I would get a lot of false presses for that button that's closest to ground. So this O key kept getting false presses. So instead, I have this kind of using a totally different strategy for press versus release. So here I'm looking for a stable voltage by just repeatedly reading the analog value every millisecond and looking for several consecutive readings that are all identical. So, identical is kind of a tall order because there's a lot of noise at the kind of one least significant bit level in most ADD converters. but it happens that this is fine. Like when you press the button, it doesn't take a significant amount of time to reach a point where during a window of 5 milliseconds, I have detected several stable readings that vary by less than 1 significant bit. So this just kind of ignores the whole section of the waveform where it's kind of settling to a new value, and it's just kind of waiting until there's a stable reading for several milliseconds in a row. Then after that point, we're just looking up the closest value in this lookup table, just closest by absolute value. So whichever one of these is closest, we press it. If it's closest to 0, nothing happens. Then we tell the Teensys keyboard emulation to press the modifier keys we want and the relevant key. Then for the release, we're actually just waiting for the value to dip below kind of a preset threshold to say this is close to 0. Now it's safe to go back to running our usual algorithm. And then we release the key. So that's the whole Arduino sketch. It's pretty straightforward. I was avoiding using the serial debugging for this because I think, I don't know, this is probably a documented limitation somewhere, but I was having trouble using the Teensys emulated serial plus HID device on Windows. It just wasn't showing up at all, so when I use just the HID emulation, it works under Windows just fine. All right, let's try this out in the text editor. It is chilly. I think I'm gonna put on a jacket and hit my head on the lights. Oh, that's much better. All right. Nice and clicky. All right. This is the USB cable here has a lot more pull to it than the Flex assembly. So when this whole thing is not assembled, I usually tend to have to tape down the USB cable. Great. Okay. That's a good sign. I kind of want to press this with, one thing I've noticed is that having my finger in contact with the ADC input adds a lot of noise, and doesn't really do what I want, so I think I'm going to put this on to do the test. So flexible. All right. It is hard to test repeated button pressing when macOS is doing its little, did you really mean one of these other accented characters thing? That's concerning, though. This is not working nearly as well as it was last time I tried it. Which means I wonder if the voltage reference this is using is not the voltage reference I think it's using. Maybe let's try a lower level test. Yeah, we just want this to be printing raw readings. Yes, yes. It's really frustrating when, I mean, I'm sure Switch manufacturers just get so paranoid about this, but like when you press a tactile switch and the moment where it clicks is not the same as the moment where it actually makes contact. So I think that's the case for this one. Next time I do this, I'm probably buying higher quality tactile switches rather than just like random ones off of eBay. It's like, for example, this is one of the ones that definitely needs replacement. Yeah, I think there were 3 right next to each other that needed replacement. Yeah. Man, so I don't know what, I assume these were just bummed to begin with because I didn't actually test these tactile switches before soldering them on. I mean, it's possible I heat damaged them, but they seem to have metal frames, so I'd be surprised. I mean, maybe I damaged them with, like, alcohol or something? Maybe I washed some flux residue into them? Oh, geez. I hope I have enough replacement buttons for all of these. That one definitely sucks. Really? spare buttons do I have? I think I need more tape also. Yeah, this is frustrating. Okay, well now the one that I taped seems to be working again. But I still might... Not this one. Jeez. That one's fine. Knock on wood. Ah, really? I don't think I have this many spares. Well, I don't know. I think I might have 6. 7. Yeah, there are 7 buttons in this bag. Maybe we can do an autopsy on the broken ones. I mean, with this many of them having trouble, this looks like something I must have done to damage these buttons. It might be worth trying to flush them with alcohol to see if that helps. Like, maybe there is some gunk in these. But wow, that's... Man. It's a lot of buttons having trouble here. I mean, that one seems to be fine right now, but... Let's see if I can reproduce this trouble with the cover off so that I can squirt some cleaning fluids in there, maybe. Don't really want this teensy sitting right on the metal surface if I can avoid it. I mean, it is painted, but I don't trust that super much. Okay, there's our map of problems. So... Trying to kind of flush the inside of the button with alcohol a bit in case there's something inside that this needs to wash out. That alcohol does seem to be conductive. wonder. I think I might get the compressed air to try to dry this off faster. You know, I do have a different kind of tactile switch, which might have a close enough footprint if I do have to abandon these entirely, but I don't think I'm going to have to do that. But there's that other kind. I'm just like looking around in the desk to see if they're even just still out here, but I got these other tactile switches that they don't have the kind of brass nubby part, they just have the dome itself. So I'd have to modify the plastic pieces to have another bump sticking up, but because I'm printing those separately, that's totally doable now, so it is an option if these are just totally bad. This is definitely not going to be a waterproof button pad. I have to say that would be neat next time though, to try to find like sealed tactile switches and then make the whole thing a lot more sturdy with respect to liquids. That's promising. I think I might do another cycle or so of that, kind of flushing the buttons out with alcohol and compressed air. Because you know, with how many of the buttons were having that same effect, and I don't think these buttons are sealed, I think it's just a metal cage with a disc that flexes inside and a couple of terminals. I probably, because like I've washed this board a couple times with alcohol during the course of making it, and I think what might have happened was the alcohol washed flux into the switches, and now I just need to like finish washing that out of the switches. But maybe these don't need replacement so much as they just need cleaning, which is actually pretty good news. I kind of want to put this whole thing on a sloped surface so the alcohol runs off. You know, the old joke about the hard problems in computer science being like naming things and concurrency. There's got to be something like that about cleaning things in electronics. Wow, if I squirt air directly into the switches, they just make rude noises. Yes, I'm cracking up at fart jokes. Tuco is kind of confused about everything that's going on here. I don't think he likes the air compressor. The A to D converter is still indicating there's plenty of alcohol around here, but maybe after it dries off a bit, I'll try testing it again. You could probably make a pretty high-tech whoopee cushion with a flex circuit board and some accelerometers and some compressed air. All right. It's close to 0. All right. This seems to have fixed it. Let's carefully try all these buttons, but the ones that were even having like a really hard time over here seem to be all right. So it does seem like there was just some flux residue or some adhesive residue or something inside the buttons. Oop, that one needs more cleaning. That button still needs more cleaning. Testing this keypad is going to be one of those things that's kind of annoyingly meticulous right now, but saves me a lot of trouble later. Because it's going to suck a lot when I get this thing totally assembled and it's like, ah, that button's not really working. Hey cat, did you bring me a bolt? You want to play fetch while this dries off completely? Hey Cheek, let me just do a first pass at all these, and then we'll play fetch while the alcohol dries completely. Man, I'm really happy that worked. So yeah, I thought I was going to need to like replace most of the buttons on here, but they were just dirty. All right, cool. That's great. Let's let that dry a little more and play with Tuco since he seems pretty lonely right now. Hey cat, what do you want? Oh, that's a good suggestion from the chat that I just noticed, to push the buttons while they're soaking in alcohol and then use the compressed air. Yeah, that seems like a great way to get the alcohol into the working surfaces too. I'll give that a shot if this doesn't work totally after it dries. We can see the A to D converter reading getting a little lower as the alcohol dries off. I know, Tuco. We've also got that print going, which looks like it's making pretty good progress. Looks like it's at the point where it's starting to build the kind of bridge parts of the buttons. Lumi in chat says, debouncing with 4 question marks? I don't know if that's a reference to the physical button or the software. As far as like software debouncing, the loop that I have looking for a stable A to D reading is also effectively acting as a debouncer in my case, because it's waiting for the button to be at a stable level for what turns out to be like 4 or 5 milliseconds. So that seems to work pretty well. It's really tempting to use the compressed air to dry off this board a little more, but I don't want to scare Tuco away when I'm playing with him. He really does not like the air compressor, which I can understand. It's like as big as he is. And sometimes he explores the closet that I have the 3D printer and the mill and the air compressor in. And he seems to like it in there as long as the air compressor's off. When the air compressor comes on, he just bolts out of that place. Good job, boy. about gluing this thing up and debating whether it's worth trying to glue just the back side to this flex PCB and then to glue all of that to the front side, or whether I should just try to do it all in one go. Doing it all at once seems more likely to work because I wouldn't glue the circuit board into a position that doesn't actually line up when the whole thing's assembled. But gluing them separately might make it a little easier to ensure that the flex PCB actually sits right where it's supposed to. Oops. I'm still getting enough leakage on this board, presumably because it's wet, that it's hovering around like 8 or 9 ADC counts, but I'm testing the buttons already and they seem to all be pretty reliable now. Alright, let's try the other Arduino sketch that actually acts like a keyboard instead of just spewing ADC readings out. I wonder if maybe it's having trouble getting a stable plateau now that there's all this like liquid related noise. Well, I might have also just made the length of the stable region a little excessive. Let's just turn that down slightly. Yeah, I think that's right. Hey, boy. So I think the final change to the software then would be turning the modifier keys back on. So now instead of just A through O, it's Shift-Alt-A through O, which should just give me some weird keys when I type in Mac. But these are things that I think I can hotkey pretty easily in Open Broadcaster. It's funny, I guess I've got an Apple button here when you plug this into a Mac. This seems to work pretty well now. I think between the software tweak to make the stable plateau a little smaller and cleaning the buttons, that was all it needed. Hey, Tuco. Let's see if we can actually show this switching channels in OBS. Or by show it, I mean I'm not actually going to do this on my streaming machine right now, but on this machine so that I can show it on video. I think I have OBS on here. Oh, maybe not. Well, hey, Tuco. Oh, you know, I do have OBS installed on the Windows machine. Maybe I'll just do that, because I don't really need or want OBS on this computer right now. Let me do that. Yeah. Alright, this is back to the computer I was running Rhino on. Maybe plug this in where the Space Mouse was plugged in. hear you, Tuco. Oh, not that mouse, this mouse. Whoops. Okay, great. So I think I do want to wait till this piece is done before actually gluing this together, but maybe there are some other pieces other things we can put together before that piece is actually done. So, OBS. So this isn't my usual OBS setup, obviously, but I've got a couple of things I can get on here, like my microscope and the printers. Bot closet is down. Why is bot closet down? I probably just need to reboot that machine. Anyway, let's see if we can use this for hotkeys. So bot closet. Oh yeah, Alt-Shift-A. Microscope. Alt-Shift-B. Just have a couple of those on there. Which one did I hotkey to microscope? That one, yeah. Of course, in my streaming setup, I would try to do this somewhat sensibly. Also, this is still the layout that doesn't have where all the buttons feel the same. So yeah, it's still a little hard to navigate, but that's why I want the key or the cover that includes different feels for all the buttons. That's pretty much the demo, I guess. I mean, I have a lot more scenes on my streaming OBS, so I'll have more things to switch between. That's pretty much it. Aside from... Oh, that's a good question. From US Water Rockets in the chat, what happens if you press multiple buttons at once? Which is a great question. I can show you what happens with both of these sketches. Let me go back to that first. Let's go back to the Mac, since I have more tools set up on there. Keyboard. Alright, so there are some buttons. If I hold this button down, it repeats because I'm just telling the OS that that button stays. I guess some of the special keys don't repeat. It's interesting. If I press multiple buttons at once, then what's actually happening is the first button that has a stable detection ends up getting pressed, and then the firmware goes into that loop where it's waiting for all buttons to be released. So generally what will happen is when you press multiple buttons, the first one will take effect, and then anything else will be locked out until you release all the buttons. If you actually press 2 at the same time, if you could actually do that, then it probably it might give you a different button because you might get an average of those 2 voltage levels, and then that would potentially be close enough to a different key entirely to be detected as that. So like if I press, the worst case, for example, would be pressing the 2 at the extreme. So like these two If I press these at the same time, then it should give me a different key entirely. So, and it just has to be at the same time within a couple of milliseconds, because that's how fast its ADC sampling is. So you can see here's each key, and then here's both together to get that different key, which is actually in the middle here somewhere. But you have to try really hard to do that generally. I mean, if you're just kind of casually pressing a second button without releasing the first, then it'll be ignored. But that's a great question. It's a good demo too. Yeah, and this is totally not the behavior you would want for a gaming controller or even like a normal keyboard, but since I'm using this as like a selector, this is totally fine, and it saves a lot of wiring. So, let's see, there's another open question, I guess, as far as the keycap colors, and I don't think they're really distinctive enough to where I can really convey much information with the keycap colors, because most of these don't stand out very well, except for maybe the green. And I mean, so like I've got some bright primary colors in here, so that's like bright green, bright blue, bright red, and so they kind of come through. But like in thinking about this color scheme, I've already got that nice subtle orange color from the Kapton. So I want something that goes with that and doesn't necessarily overpower it a lot. So the green and the red I don't think go with it at all. I think the blue works. The white and black definitely work. These are mostly white. That one's black. The black insert actually might look the most similar to just no insert at all, because that seems to match the look of the thinner NinjaFlex here on top of the black background. Let's try putting the backing piece under all of this too. So, yeah. So the white inserts end up looking, well, the white and black inserts are both pretty subtle. I don't know, I kind of like the blue ones, because that's like another little bit of extra color, but it kind of goes with the orange. It doesn't really overpower it too much. But the other concern with this was in my actual keycaps here, I've got those holes that I don't like. So the blue here actually looks kind of gross, and whereas the white looks better. So I think I'm going to defer that decision until after this next 3D print finishes. So let's see if I can maybe attach this to the bottom side, or if that's worth doing. So I think the first step is probably actually to put the magnets in. And I kind of want to glue the magnets a little bit on their underside, so I think I'm just going to kind of dip them in glue and then stick them on here and try to get them all going in the same direction if I can. Let's see. Maybe have a little thing of glue. This is E6000. It's, I don't actually know what it's made out of. It's some kind of weird polymer that has like an endothermic hardening reaction after it's exposed to air. So I think what I want to do here is just take the whole stack of magnets and dip it in the glue, then like stick one down and kind of slide off the rest. So I'm gonna try. That might have been too much glue. So I think like that. Yeah, I think I might be adding a little too much glue. I want to avoid that. This stuff is really thick, so I get like a nice gooey layer of it on the magnet when I dip it in there. I wonder where the cat's hanging out. Let's get a different camera angle. Sometimes I get jealous of the maker type folks who have like a whole video crew just covering what they're doing, but there's also something I really like about doing it all myself, even though it takes a lot more time to do both the video and the making. This would be so much harder if I didn't have this down on a metal plate right now. Alright. Oops. Still not totally sure I'm keeping the polarity straight because I've like dropped this and picked it up potentially from a different side a couple of times, but I don't think it matters that much, but it would be nice to keep them all the same polarity, so I'm looking for a way to test that with something in between this and the magnet that is non-ferrous. Like, maybe this. Yeah, so far that repels all of these. So that means this is the right side. That's safe. Great. It'd be better if all the magnets are pointing the same direction, because then it won't be as prone to stick to itself. You can kind of even just like slide off that top magnet by hand, given the deep ridge in the NinjaFlex. That's nice. hate getting this stuff on my fingers. Potentially wear gloves for this part. It's actually not hard to get off, like it dries into this stuff that just kind of peels off, but it's just, kind of gross, and it seems like the kind of stuff that I'm really likely to get some kind of contact allergy to. It's, This would be easier if I had a larger stack of these same magnets, but these are all the magnets I've got, so I'm holding it with the end of a metal ruler. Four more. I'm really glad that at least the magnets and the glue are two different kinds of sticky. Oh, one more magnet. Now this one, I'm going to have to apply the glue a little differently. I think I might just put some glue in the hole this time instead of on the magnet, which might have actually been easier this whole time, but well, it's harder to get the glue in just one spot without strings everywhere. But it does make it easy to get the glue into just the right spot. Alright. That Ninjaflex is fully magnetized. So now this piece has a very specific little hollow set aside for it. So for getting that in there, I was actually thinking that maybe the best adhesive to use for that job is Super 77, which is a spray adhesive. And I think it stays pretty flexible even after it's dried. So for that, what I would do is just put this on top of some newspapers or something upside down, spray it, and then just stick it back on there, lined up very carefully. So I think that's what we're going to do. I am going to... Oh, that's a really good question. I'm losing my train of thought slightly, but from the chat, there's a question that, what are the magnets for? That's so that I can attach this to these metal poles that I have around my studio, because that's kind of ultimately where I want this to hang out. So that'll help it wrap around, for example. Oops. Like, this is my current solution. It's a numeric keypad that I have stuck to here with magnets. And it's all right, except that the main thing I don't like about this is that all the buttons feel the same, so it's harder to tell where I'm pushing. There's like a very subtle bump on the 5, but even that is super, super subtle on this keypad. So like when I'm just holding it, I can't tell where my finger is. So that's part of it. But I also just wanted this not to be wireless. I wanted it to be wired so you don't have that delay when it wakes up the first time you press a button. And I wanted to experiment with trying to make something that conforms to the shape of this pole, so it kind of wraps around instead of just sticking on top. So that's the reason for both the magnets and the flexible structure, because these are kind of weirdly shaped. And then I can also kind of bring it to different parts of the shop, and if I'm streaming near the whiteboard, I can stick it to the whiteboard. It also might stick to the metal parts of these desks or the folding tables. All right, so I am going to actually need a quick restroom break, but then I'll come back here with the Super 77 and we can try putting this part together. Yeah, Super 77. So it goes back. Go. You are right where I'm planning on spraying some glue. God. So. Let's not have this camera about to stop itself. What's up, cat? Okay. delightful. Alright, it is now pretty thoroughly sticky. So I'm going to try to carefully line this up as I stick it down. And get my head in the camera. Oh, let's not stick that down before I can actually see what I'm doing. This camera is in the way. Now this glue is working fine, I think. Just want to make sure it's actually in a good spot. This would maybe be a little easier if the NinjaFlex wasn't clear. Just kind of lightly pushing it down so that it's flat while making sure that it's actually in the little channel that it has available. More methodically press it down starting from one end. Great. So that is not an amazingly strong glue job, but it will be more than enough to hold this in place while I glue the rest of it together. And it might actually end up being kind of strong, we'll see. It just shouldn't necessarily have to be strong. So, how's the print going? Well, I think at this point we're waiting for the 3D print to finish. Because this, this will do fine for gluing up the bottom half. I don't think I need to worry too much about doing the top half before this glue dries, since if there's any excess E6000, it's pretty easy to peel off. So I'm not really worried about that getting in the way. And I have this piece that we could use, but this one. But I really want to see if I can get one without these holes in the top, which I think these were just the result of switching to 0.1 millimeter layers instead of 0.15 millimeter, and it wasn't quite as good at the bridging. So we could go ahead and assemble it with this, but I think we can do better. So what I might do, since I think I'm a bit at an impasse right now, is just wait for this 3D print to finish, and then I'll start up another stream and we can finish putting this together after the 3D print is ready. I see some areas here where there's like a darker color, which almost looks like E6000 has seeped under the NinjaFlex, but I don't know. If that is actually the case, then it should just end up having to peel off the metal after it cures. Those should be solid, but because it's only 2 layers, maybe they aren't actually watertight and some of the glue seeped through. We'll find out after it dries. But it's getting pretty close. It pretty much just needs a less broken version of this piece to go over the top. And other than that, on this stream we fixed the switches, fixed the firmware. Just needs a top. Tuco, do you want to play a little bit before we end this stream? Well, Tuco sure enjoys his bolts. It might be about time for he and I to get some lunch. Meow. Happy hacking, everyone. Thanks for tuning in.